If your coffee machine is struggling, if it's not working, if you're not able to have your lovely coffee in the morning, don't throw away the machine. Just give it a shot. Maybe you're able to fix it. But in order to attempt fixing a machine like this, you must understand how coffee machines, espresso machines are working these days. Without further ado, I'm gonna go straight away and explain you how everything happens here. Right when you put the water tank filled with water in its position, the water starts to flow immediately into a flow meter. It's a device with a yeah, it looks like this. On one side water is coming in, on the other side water goes out, and inside has some magnets around the propeller. When the water is inside the machine, this spins. The PCB board, the microcontroller, know that the water tank is connected to the machine. After the flow meter, the designer placed a water pump. So the water pump is sucking the water from the water tank and sends it into different directions. The cold water from the water tank first goes through a steam boiler where the water is a little bit preheated and then is sent into the coffee boiler. Here, out of the coffee boiler, there is a valve, a solenoid, and the water goes to your group head. Here is the coffee, yeah, coffee pod, and you have coffee into your mug. Sometimes you have a second pump who draws water into a steam boiler, but oftenly you have a splitter here and some water goes into a steam boiler, yeah. And here you are having, yeah, through a magic wand you can make froth milk, yeah. Here is the cup. I don't know if I can make myself clear, but in order to basically troubleshoot these machines, you will have to follow a few steps. And most common scenario is the one in which the machine is not outputting any water, no steam or no water. In order for you to be able to provide the basic troubleshooting for your machine, you have to follow some simple procedures. For example, if your machine is not outputting any water here on the group head, or you don't have any water, any steam, but you can hear the water pump working, you hear an electric motor sound, what you have to do is to one by one remove the connection between the hose and different places, yeah. If you have no water, in our case here, what I would do, I would remove the hose here and one at a time here, yeah. You can't remove it here because the water will never the air will not, you will not be able to blow air through a pump without the pump being activated. The pump is blocked usually, yeah. Also, these valves, yeah, solenoids are blocked. You will not be able to blow air from here to here, yeah, without power. So you remove one side of the hose here, one side of the hose here or here, yeah, and you blow air here, and you will be able to blow air by this direction. The air will go like this, through this, and it will exit here, yeah, in the points where you remove the connection. If you're able to blow air from here, from point A, let's say A to B, where you disconnected the hose, it means that all this path is not blocked. Also, you can remove the hose here, and then you can remove it here, yeah, from point C to D. If this is put back together and this is connected again to the, yeah, to their here to their connection, and you blow air in point C in this tube, the air will travel to the boiler, to the steam boiler, and it will exit here. And you will know that these two tubes are not blocked. If all these pipes are clean and you find you test them by removing an input and an exit, yeah, let's see, E and F, yeah, and then you remove this one. Blow air in point E, you should have an exit on a point F. Yeah. If not, somewhere here the tube is clogged. Pay attention that if you check all these hoses and they are perfectly clean, no problem with them, you might have an issue with these solenoids. Of course, if the boiler are not clogged or they are functioning. Yeah? The solenoids have some water inputs like here, one input and one exit and another exit, and they have two terminals which go, actually three terminals. One is live, one is neutral, and one is ground. And what you have to do in this case is to remove here, yeah, one of the connectors and measure between live and neutral with an ohmmeter. You place the meter on these terminals and you should have like 2 kilos, 2 kilo ohms or something like that. Also, in case you're suspicious about the functioning of a solenoid, you can take it apart, yeah, and see what's inside. So, in this video, we are going to try to fix a coffee machine. It's a Breville One Touch V146. And the problem with this machine is that it doesn't output any water, so no coffee, no steam, nothing. And after I took the unit apart, which I didn't show you because it's not that complicated to do, I noticed that the heating boiler was very stuck with calcium. It was basically um, one of these hoses which connects the pump through three-way adapter was totally blocked. I had to take the boiler outside of the unit and give it a proper cleaning. I'm going to show you later what happened by now. After cleaning, I hope this device is going to work properly. So, how does this machine works? When you set your water tank here, the water flows through this filter here and goes to a flow detection. Here is a flow detector, which is a device with some magnets who create a electromagnetic field which is detected by some component and sent to the microprocessor in order for the unit to know that there is water present inside the machine. After the water flow detector, the water travels through this pump. This device here is a water pump, yeah, and exits through this hose into a three-way splitting adapter. This one here is a three-way splitting adapter. As you can see here, the water comes from the pump and it has two exits. In our case, one exit goes to a steam chamber, a steam boiler, and the other one goes to the water boiler. The steam is creating high pressure water vapors, steam, in order for you to have froth milk, and the other output sends the cold water into a boiling unit that is outputting hot water that is directed to the coffee pod. And this way you have hot coffee. After I took the unit apart, I knew that the pump is working because the machine was struggling to it. You can hear a weird sound. I knew that the pump is working. And then what I started doing was to take apart these little hose clamps here. Yeah, like this one, you need a long nose plier. And I start blowing air through these pipes to see if it's a blockage, if any one of these is blocked. Luckily, I didn't have to do that's too much time, because I noticed that the input of the boiler, this is the boiler. The boiler has a hose connected, as I said to you, to one of those three-way adapter. Yeah, it's coming right there. This hose comes, I don't know if you can see right here. Yeah, the hose from the boiler comes here, and I noticed that around this hose here is a lot of corrosion. I blow air even on the other side of the hose, and I notice it's stuck when it should have been basically free. The air should have been passing freely. I tried to take it out, but it was very, very badly stuck inside. So I had to use a mini drill to drill holes in the middle, scrap it out, and then I use a flat screwdriver to remove this this copper piece of metal, which is attached to the hose, and because of the calcar was attached to the body of the boiler. I took it out, and I noticed then there is no other clog inside the machine. Now I will explain you how this boiler is working. As you can see, the boiler has an input and an output. This is the simplest boiler on the market. On one side here, the one I talked about, is the water input. It comes from the water tank. And on the other side here, the water goes to the, of course, it goes via some pumps, some valves, sorry. It goes via some valves to the coffee pod. It goes to your mug. Here, these terminals are the terminals of the heating element. This one are powered by the mains, and it's basically a coil resistor, a powerful resistor, which is inside the walls of this boiler, and it's circulating in a coily way. The current enters on one side of the terminal, travels through the interior of the boiler, and goes on the other side here. On the same body, you have some clamps which allows you to attach different kind of sensors, like a temperature switch and some temperature monitoring devices. There is a diode here, and I think it's a thermistor. After removing the hose, I had to open the entire boiler. This is how it looks, so that I can clean it properly on the inside. And here you have to be careful about a few things. First things first, never use very sharp objects, especially on this trench here, because here is an O-ring which seals the water, doesn't allow the water to flow outside of the unit. If you scratch it, then you're gonna have leakages. I will show you very soon under the microscope how it looks inside. Just bear with me a little bit. So I put this part in some vinegar solution, and I let it for 1 or 2 days. Apparently it didn't solve the problem very well, because corrosion is still present. Sorry, corrosion, yeah, and a lot of residue from the water. The previous owner of this machine, didn't took too much care about it, and it ended up almost in the bin. Let me show you now under the microscope how it looks, what calcar is doing to your coffee machine. This is cleaned, but obviously, I told you it's clean for a couple of days, but still you can see, look, this is calcar, which sticks everywhere, inside the hoses, yeah, inside everywhere. Be very carefully when you scratch or if you scratch this residue from inside the boiler, because here is you have an O-ring, and if you scratch it badly, the hot water might leak, because it's pressurized water and might leak outside. This is how it looks, the bottom plate of the boiler. As you can see, it's full of scale, of calcar. This is calcium, basically. You can see it's pretty nasty thing. Yeah, it's a very pretty nasty thing to have on this device. This is the upper body of the boiler, a water boiler, and you see inside is still a lot of residue after 1 or 2 days of keeping it in vinegar. Calcar deposit, calcium deposit from a very bad water, from tap water. The owner of this coffee machine didn't took too much care of it. He didn't clean it very oftenly, and you can see everywhere this residue. Now, if you check all the hoses, all the inputs of the splitters, and you didn't see any blockage, nothing, and you can still hear the pump trying to work, then most likely one of the valves is gone. In order to check these water valves, you must remove one of the terminals, and using an ohmmeter, you must measure the resistance across these terminals. It should be about 2 kilo ohms. Yeah, 2.37 kilo ohms, as you can see there, which means that this valve is not broken. If the resistance is very low, like 10 ohms or full short, you must replace the valve. This doesn't allow the water to flow further. If the valve is broken, take it apart, replace it, and everything is going to be fine. Also, sometimes it's possible for the valve to still be good, having a good resistance, but something might be wrong inside. The valve might be broken. Yeah. How you can test this? This is kind of complicated. You could power the valve and then blow air through one input or to the other one and see if the water is flowing when the pump is activated. Or you can open the valve, take it apart. Here it has a nut, and basically you can remove completely the valve. After removing this nut, you can expose the internals of the valve and you can clean it. This only if the valve appears to have a good resistance. Now the only thing left to do is to find a new replacement hose to connect it between the boiler and the water pump, hoping that it will work. It is not easy to find this part, but I keep digging online for an option. Maybe I'm going to buy from eBay a cheap broken identical coffee machine. Thank you for watching. Like and subscribe, and see you next time.